We're now going to look at a variation of this alpha halogenation reaction. We're still under basic conditions, but we get this specialized reaction when the starting material is a methyl ketone, meaning you can have anything on one side of the ketone, but if the other side is a CH3 group, that's a methyl ketone. If you have this, a special reaction takes place, which is known as the haloform reaction. And this is an important chemical test, and we'll discuss why that is. So let's start with this starting material, acetophenone. So if we react this with sodium hydroxide, and for now I'm going to go ahead and be generic and use, I'm just going to write X2. So X2 can be Cl2, Br2, or I2. And because we have 3 hydrogen at the alpha position, like the previous reaction we discussed, all 3 of those are going to get substituted with a halogen. So we'll end up with CX3. Now we have a molecule that has no alpha hydrogen. So we're kind of stuck as far as putting anything else at the alpha carbon. So then this comes back to a reaction where a nucleophile attacks a carbonyl carbon. So what can happen from here is, since there's no more alpha protons for the base to react with, the hydroxide can attack the carbonyl. Now, that's not to say that this can't and doesn't happen before this stage, but in general, what happens when a hydroxide attacks a ketone is it might attack, you'll get this intermediate, but those electrons will come back down and you'll lose the hydroxide, just reverting to starting material, so it's non-productive. But the difference in this case is because we've trihalogenated the carbon, this actually becomes a good leaving group now. So what can happen when that pair of electrons comes back down here, instead of losing the hydroxide, this can lose the CX3 group. So what we're left with is a carboxylic acid plus CX3 minus. Now we have a negatively charged carbon, an acidic carboxylic acid proton, so then fairly rapidly those two things will react. That'll take the proton, end up with HCX3 plus the carboxylate. So depending on what halogen you use, we get this product, and if it's the Br, this is called bromoform. If it's a Cl, chloroform, and if it's an I, it's called iodoform. Now, chloroform and bromoform are liquids. Iodoform, and you'll notice I wrote it in yellow, iodoform is a yellow solid, a bright yellow solid. And this can be used as a chemical test for methyl ketones. So if you have an unknown, and you know it's a ketone, but you don't know if it's a methyl ketone, what you can do is add base and I2 to that. And if the reaction produces a yellow solid, that's a confirmation chemical test that you have a methyl ketone. If you're just doing the chemical test, this is all you would do. You would stop here. If you see the yellow solid, that confirms the methyl ketone. If you don't, then you don't have the methyl ketone. Now, at this stage, you could, if you needed the carboxylic acid, you could add acid to this and protonate that oxygen. But usually, if you're just using it for a chemical test, once you've ran the test, you just discard the materials.